To transfer charges in a closed circuit, a source of electrical energy expends the amount of energy equal to the product of the source EMF and the amount of electricity transferred through the circuit. However, not all of this energy is useful. That means not all of the work produced by the energy source is transferred to the energy receiver, because it partly spends on overcoming the internal resistance of the source and wires. Thus, the source of energy produces useful work equal to the product of the voltage and the amount of electricity, where U is the voltage at the terminals of the receiver, Q is the quantity of electricity, which equals to the product of the amperage in the circuit and the transit time. The formula of work can be represented as follows. If, however, we represent the voltage at the terminals of the circuit as the product of the current strength and the resistance of this section, the formula of work can be written as follows. However, none of these formulas describes the size of the electricity generator which this work is obtained from, because both large and small generators can operate with similar result, but within different time intervals. Therefore, the size of the generator is determined not by the work done, but by its power. Power is the work done or consumed over a second. Power is evaluated using the following formulas. Is evaluated in Newton meters or watt seconds, that is in joules. Power is measured in watts. It follows from the formula of power that with very low external resistance R, the amperage in the circuit is high, and the voltage at the terminals of the generator is low at that. When the external circuit resistance R is equal to 0, the voltage at the terminals of the generator U also equals 0. Consequently, the power P given to the external circuit equals 0. At very high external resistance, when the external circuit is open, the resistance is infinite, the current strength in the circuit is 0. The power given to the external circuit, even in this case, equals 0. Thus, with increasing resistance of the external circuit, power first increases from 0 to a maximum value and then drops back to 0.
Наибольшей максимальной величины, а затем убывает до нуля.